Okay, so first we have Jake.
Yeah, so my hack was doing Lomscargle periodogram for AstroPy. And the thing that I basically started out with was I took 4 implementations of Lomscargle that are all over and put them all in a similar API. And you can see that I have the fast version, which is the nlogn one. I have this matrix version, which is a little more easily extensible but slower. I have the SciPy version, which actually calls into the Lomscargle on SciPy and adjusts the normalization so it matches the others. And I have the slow version, which is like if you just go through the Lomscargle paper and code it up in Python, this is what you get. And then I have the wrapper, which I'm pretty excited about because there are 2 big challenges with Lomscargle that I've found working with students. One is choosing the right frequencies is really difficult, and this kind of gives you some automatic tools for doing that. 2 is figuring out the units of the various inputs and outputs is sometimes confusing, and I'm writing this to work with AstroPy units. That part is still in progress.
Should I create an issue? I think you're missing an R.
Oh yeah, nice. It's true. Heuristic. And then as for my demo, this is my demo right here. Python setup.pytest. 84 passed. Woo! So all the algorithms do the same thing, which is good. I wrote some of them first. Yes.
Is it in a separate package, or are you going to add it as PyStats? Or?
It's all right now. It's in an affiliated package, and I'm planning to just make it good to go, and then start the discussion of whether it belongs in AstroPy itself. And
then is that a chapter in AstroML? Where's the?
It's this will actually replace some of the code that's in AstroML. So,
okay. So the discussion about Lomscargle is already in the text.
It's in the text.
Okay. And just fair disclosure, Dan, we're live streaming and recording and all that. Yeah. So everybody knows.
Cool. Yeah. So Kelly and I were working on getting this Sphinx extension called Sphinx Gallery, working with the AstroPy documentation and moving some pieces of the documentation that fit naturally into this example or snippet gallery, getting them to work in here. You can see one of them is still broken. Learned some very nice things about what this extension can do. So for example, now the Wi-Fi's not working. Oh, there we go. So if you build one of these, which starts as just a Python module.py file in an examples directory with comments, it knows how to separate out the comment blocks and the code blocks. And then if you want to download the file as a IPython notebook, it knows how to put those in the appropriate cells. If you tell it to, it will turn all of the code that it can resolve into links to the documentation, which is pretty nice. So that even works for, I don't think I have an example of Matplotlib or NumPy in here, but it will work using intersphinx across different documentation sets. So you can link all of the Matplotlib functions you call directly to the Matplotlib documentation, which is pretty nice. But since this is just AstroPy, it'll link to the AstroPy docs. Let's see, what else? We opened an enormous work-in-progress pull request that we're slowly hacking away at, and I've opened a ton of issues on the Sphinx Gallery main repository that the author is probably scared at now. Yeah, if you'd like to contribute an example or a snippet, we'd love to have you do it. It's just a Python module, so it's very easy. You just need to add some text and then.
And we made a template for doing the examples, and I think I would also appreciate even if you don't want to write the whole example, but to nominate examples, if you find text that's like, oh, this would be a really good example, to make an issue and with a link and say this could be transformed into an example.
Totally.
You should add a label on the issue track about that.
Okay. I don't think either of us can, but.
No, I should.
Yeah.
Yeah.
Is there a way to make different categories? So like if once there's 100 examples.
Yes. Yeah. So the plan is to split this up by sub-package and then have a general examples section as well.
Is there a way to just in case an example falls in 2 different categories, can you make it appear in 2 different categories?
That's a good question. A lot of stuff like that is not implemented. Yeah. Like there's no way to turn this off. Things like that. So.
Eric.
I'm going to talk about 2 hacks
sprints, whatever I did today, or yesterday. So the first one I'm demonstrating here, which I like to call, it comes up, there it is, my flight hack. So I spent all of yesterday trying to book a flight. It turns out Delta's website times out after about 3 minutes, so if you keep getting distracted by all the cool stuff that's going on, you can't do it in an entire day. The other thing I worked on was
No solution,
this.
just the statement
Yeah.
of the problem. It's like,
Yeah,
fix an
exactly.
issue.
No, it was a hack. It was an unsuccessful hack, right?
Oh, I
Some
see.
hacks are unsuccessful. That's right. Someone could put it on the issue tracker if they want. Was this also not unsuccessful but incomplete hack on what I actually said I was going to do, which was try to develop a distribution class that is basically a quantity with a Monte Carlo dimension, so that you can use that as a sort of Monte Carlo error propagation technique.
That would be nice.
Exactly. That would be very nice. So it's, what am I at? 11, I think. Yeah, 11 of like 15 tests passed so far. But what I actually think is really neater about this hack is that it's an example of, what did we came up with an acronym, Tom. What was it? PTTD?
Yeah.
Pair test driven, no, PTDD, pair test driven development. Because you can see here that the top one is the work I did on implementing the code, but the tests were all written by Tom, or at least mostly written by Tom, based on an API that I developed. So at the same time, we were developing the tests and the API at the same time, which is really enabled by this feature that Tom pointed out to me. PyTest allows this -f option, which, let it do its thing for a second. So it ran the tests, that's normal. But let's say I want to make a change, change this test. Yeah, I think so. So if you do, so I just made a change. Now I save that file, and the test automatically runs, and it tells me, oh, there was a failure right there. So this turns out to be extremely valuable for a hacking situation, because as you may have noticed from my last hack, I was very distracted the whole day. But the tests were all there, so I could just go back and figure out what I was doing by figuring out which is the test that was failing, because that was then the thing I was currently working on. So I think this hack was more on the methodology than it was on the actual functionality. But I do hope to finish the functionality this afternoon, too.
So just to repeat, PyTest -f will, every time you save it, run the test?
Exactly.
Any file in the repo, or just the test file?
It takes whatever the normal PyTest arguments are. So like in this case, here I'll show you how I was invoking
And do
it.
you just
change,
control
if you change the code, not change the test file, it'll update.
That also
Yeah.
works any file, I think so. I think
Yeah, I think if any file in the repo changes, it will trigger it. So like, yeah, you're right. I was showing you changing the test, but I could just as well have changed the actual file that implemented it. And that's the most useful way, because then you make a change, you save it, and then the test runs and tells you whether your change fixed it.
The -f flag requires, I think, PyTest exist.
That's right,
as
yeah.
a plugin, so just do pin
There's a plugin you need to
PyTest
make it
exist.
work, but
Yeah.
Exist?
Exist.
This is a parallel run.
So,
yeah.
does
Anything
it
else,
work
Eric?
with Python setup.pytest?
Let's switch.
Yeah.
Let's switch, Tom.
What is that?
Can you use the Python setup.pytest?
That's the rub. I think not. It might be possible. So the difference, what he's talking about is that if you want to work on Python, let's say, you have to actually compile it every time, unlike normal Python files, and that does not work because it doesn't know to talk back and say run the compiler.
You can use it for people on deck, if anybody else wants to get in line.
Someone already said it.
So the -f basically checks if in files and essentially any other
To be fair, it was 2 different flights I need to book.
Big enough?
All right, now we have Tom A.
Okay, so this is my hack. Recently an email arrived to me, dear astronomer, please see the attached catalog of mystical sources. The ones with B-V greater than 4 and within 3 degrees of +25 and -15 seem interesting. Suggest you have a look. The file is nicely self-documenting. Hope you don't mind a 1.8 gigabyte attachment. Yours truly, Hyperion. And I'm thinking, well, this is the god of light, and he may have something interesting to tell me. So, indeed, I download the file. It actually went through the mail and through the spam filters. And I look at it. And it's 1.8 gigabytes. So what's the great file format that Hyperion invented? He may be a god, but he's not very good at coding and data analysis. And he's sort of like a sloppy astronomer that thinks it's clever to do things like put random header garbage into the file, put column name and definitions in weird places. So
He's sounding more and more like a real astronomer.
Yeah.
yes. So I look at the file and it's like, oh God, look at that. There's just random junk up here. And look at that, he's decided to follow the radio astrologer and put stuff like that just because he thinks it's clever. Well, here are the column names. And indeed, the data go down there, and for some reason, he feels that the sources each need a daily horoscope, and we're not too interested in that. I want to just get to the meat of the problem. Okay, so how are we going to do this? It's actually a big file. He's also, of course, chosen to distribute it in ASCII, a very large data set in ASCII, which is not optimal, but he's Hyperion, so you're not going to comment back to him. So here's the rescue. AstroPy chunky reading is coming to the rescue. So the plan is that we're going to read that 100 megabytes at a time and then stack together and actually do filtering of the results on the fly to pull out those interesting sources and then store the results. So we just do the usual, importing the ASCII reader. We're looking at angular separation to find our sources within the specified region of interest, and VStack at the end in order to stack those chunks. And I've defined a little function here, find interesting, that takes as input a table, and then it returns a new table that meets these particular criterion. One is that the B minus V is greater than 4, and the other is that we're within 3 degrees of angular separation of sources on the sky. And you notice I've used a not public method of AstroPy to do this. This has been a long-standing discussion about that. So anyway, here's the story. Now I have this function called read mystical. It takes a file name, and here's the chunk size. So I'm going to ask it to read data in chunks of 100 megabytes at a time, and I've specified the interesting columns. I don't really care about the daily horoscope for each of these sources. And you go back to what may look like a familiar function, ASCII.read, but in fact there's a new parameter allowed called chunk size, and that says in what size chunks to read this at a time. And you also have to pass guess equals false. It doesn't do guessing in this mode. So you got to know a little bit about the format of your file. And you notice that this is not returning a table, but it's returning a generator that's going to give you tables. So here's the code. I'm just setting up a Python list to capture the table chunks. Each one is a table. We're going to go through that chunk generator. This is now going to be a bona fide AstroPy table. We're going to pass that into find interesting and select out the sources that we like. And then if there are some interesting sources in that chunk, I'm going to append that to our table.
Give me another minute, Tom.
Okay. Sorry, I'm almost done. Well, so let's go and let's pray that it works. Oh, you got to be kidding me. Global name find interesting is not defined. Oh, sorry, I didn't run that one. Okay, so now it's reading out sources 100 megabytes at a time. So this will finish in about 18 of those in a finite time. But if you look at the memory that's being used on the side, notice that we haven't gone over 300 megabytes, but we're definitely not getting into the 1.8 gigabytes range. So that's good. We're actually reading this in without clobbering our memory, or so you would think. So anyway, there's going to be a story, and sorry that I'm taking a little bit longer. So now we just stack those up, and we've got our table of 1660. And that's an accident that we got a 666 in there. It's not by design. Okay, So now another email arrives. Hey Tom, I added some new mystical sources and now the file is just over 2 gigabytes. So no problem, this should just work. I'm going to run this with my new file, the V2 file.
It works because because Hyperion didn't change the file format, didn't
Yeah,
change the.
yeah, nothing else changed. Okay, but now look at the memory. Oops. We're not getting anything coming out, and the memory is climbing and climbing and climbing. We went from 1.8 gigabytes to 2.0 gigabytes. Something fundamentally changed. So I'm just gonna tell you that it doesn't work. And we're going to go to Cursiu mmap. Turns out that memory map appears to do exactly what you want and let you map a large file and pull out chunks of it at a time, but it doesn't. And you get into this situation I don't understand where it just starts using way, way, way more memory than the size of the file. So that means that this was a partially successful hack. I got some good ideas, but I have to start over with a different implementation.
And that's not a Python 2.3 thing.
I don't.
Can we take questions while we switch?
I don't know.
Was this
But we
on
can-
2 or 3?
This was a 2.
Oh.
Are you actually using the memory map? I mean, I thought you were.
This is in the
file
fast.
today.
It's in the fast reader. To interface with the C layer. So the idea was to do this all within the the fast C reader to make have big files and read them as quickly as you can.
When you're reading just the chunk sizes are the same, I mean, does the reader not wait independently for the chunk?
No, it starts the reader and then it goes through chunks.
Okay, yeah.
And what's the status? So is there a fork or an issue? What's the?
I mean, I have a pull request up, but it's never going to get merged because it's wrong. It doesn't work if your file is over 1.8 gigabytes.
Want help, or is it just staying on your action item?
I mean, if anybody knows about mmap and like the horrors in that kind of layer, please talk to me. Otherwise, if you say just punt and do it differently, then that's an answer. But definitely, if someone has experience and knows about this, I would love some help.
Okay, and so there's an open pull request to the AstroPy repo.
No, actually, I didn't put it up because I was like this close to putting it up, and then I wrote this test, and it failed, and I was like, well.
Email Eric Bray.
Yes. Yeah, I know. He knows. Yeah, he knows all about this stuff.
Cool.
But I think Eric's.
Yeah.
Thanks.
Sorry.
All right, Stephanie does it.
So I have 2 hacks that I've worked on this week. One of them I worked on yesterday with Drew, Sam, Jess, and Mike, and that was we wanted to design an middle to upper level undergrad lesson integrating an astronomy, some astronomy content with learning programming practices. And there was some brainstorming and comments about teaching development. So we came up with the astronomy goal, which I think we might iterate on, was saying that learners will be able to relate sort of the peak of a star's SED or the peak of its photometry to the color that you see. Or we actually realized we might be able to actually get them to figure out what photometric color is, so subtracting one band from another. And I'll get to how we figured that out in a minute. And then we created a rubric for that. And then we also decided our programming goal was reusable code. And so doing things like writing functions, making sure your code is documented, that you're inspecting data efficiently and not printing tons of stuff out. And so what we decided is that we would give students, I know I'm scrolling through this, I should have done this differently. We would give students SDSS photometry and a picture where they could see the visible colors of the star. And then they would just basically get to play with the data for a couple of hours. And then at the end, we would say, what can you learn about these stars? and then at the end ask them to make a plot relating the star's visible color to something in the photometry. And so we each sort of sat down and said, like, okay, I'm a student, I'm an undergrad who doesn't, who's never encountered this before. So we give them the photometry file, which is this stars file, and just have them start trying things. So this particular student, who is me, tried plotting magnitudes against each other. That doesn't tell you too much. And then adding, so this is R versus G with this visible color here. And I was trying to use good programming practices and had to iterate on that. So that doesn't tell you anything. Now they're plotting the stars, the magnitudes as a function of central bandpass. That doesn't get them anywhere. And then they plotted, so that now you have 5 color SEDs, or 5 band SEDs for all the stars. And the red ones are the steepest, and the orange one, and they get, as you go through to blue, they're getting less steep. And so how can you quantify that? And then actually, so I tried a magnitude difference and then sorted, and it actually brings out, as you would expect, the visible colors of the star. So, I mean, I did that fast with giving, and without doing a lot of the programming practices stuff, but that's, but so for example, there's writing, for example, here's a loop. So you could define a function to do some of this calculation. And so having students go through this process to understand what we mean by astronomical color is actually not impossible.
What's the future of the?
I think we haven't laid that out yet. I think we might need some more iteration, and so we sort of ran out of time yesterday to talk about where it was going. But I think the goal in my head would be to get it written to the point that we could post it somewhere and someone would teach it, but I no longer have students to teach for the next couple of years, so if someone wants to volunteer, let me know.
Well, so I'm curious, we did not have this on conference session, and maybe we should talk about it this afternoon, is what repositories we're going to use for educational resources and for teaching notebooks.
Yeah.
Because Tom Aldcroft and a Google Summer of Code student worked on setting up some infrastructure on astropython.org, but it needs to be populated with materials. And so anyway, there's some community work to be done on that front.
Okay.
Next one?
The next one. So I was working with Brett and Eric mostly on putting together a scheduler in AstroPlan. So Eric had already come up with one where you give it an observatory site and a set of targets, and you set up some empty observing blocks, so they have some information about constraints, but they have no start time and end time. And then the scheduler that Eric wrote just said, oh, it's really hard to see those. Basically, it says, okay, what is the most optimal target to observe right now?
Scroll up, just move the plot up, figure out.
I can't. Okay.
It's at the bottom.
Hang on.
That's okay.
There we go. What's the most optimal target to observe right now? Observe that, and then go to the next block, or once that's done, what's the most optimal, and it just progresses through, which is useful if you have a bunch of like targets that are scattered all over the sky. Just pick what's the highest one right now. But then the scheduler that I wanted to work on was a prioritized scheduler. So say you have a set of targets where this is my most important target, and then go down from there. How do I set up my observing night? And I used more targets because I wanted more conflicts. And they're just bright stars. And so what mine does, and I don't have it open, is that it says, what's my highest priority target out of all of my observation time? When is it most optimal to observe? So it fits all the constraints and is at the highest air mass, is what it does right now. And then it slots together, and there's some errors, or some problems from AstroPy. And so then it schedules that block, and then it takes the remaining time and goes to the next priority target and schedules it. And then you get out, this is, oh man, you can't see the colors. I'm sorry.
Oh, is there supposed to be shading?
They're supposed to be, you're supposed to be able to see the block. I don't know why they're not showing up. But, hang on.
I see some purple ones.
Yeah, there's one set. I think there's alpha set on here.
I think we can.
Yeah, hang on. No, I want to do this. It will. The plot doesn't take long. I'm not rerunning the whole thing. So there you go.
Nice.
So, so this is 2 nights, and so it, So it scheduled the first night, but some of them had conflicts, so it moved them into the second night. And same with the targets at the end of the night. So you could schedule, in theory, you could schedule a whole run this way and lay out when's the optimal time for all your targets. It's a little slow right now and probably needs some optimization, but I mean, for me, I could use this, and so I'm excited.
What is the word? Is it like development? What's the push? What's the distribution plan?
So there's already a pull request up for it to go into AstroPlan, and Brett's going to talk about AstroPlan later.
Okay.
So actually,
So it will be,
but this was the part that I did.
functionality included in AstroPlan.
Yes, that's the goal, and I think there's a Google Summer of Code.
Let's switch speakers while you take questions.
Actually, it's a comment, which is that you could consider advertising this to amateur astronomers to schedule for the message and then find the optimal link.
Oh, that's not, yeah.
That is not HTML, is it?
Yeah, it is.
No, that's not. Oh, that is. No.
This is what HDMI looks like in my head. Is it too big?
What did you just have plugged in? Is it?
No, it's not HDMI. It's like a weird new version of HDMI.
Yeah.
Which had me annoyed because I think this computer
So it doesn't-
advertised as HDMI.
Wait, so what?
There is a regular HD.
Oh, there was a thing on a thing. I see.
It takes a village.
I did want to ask follow-up question there was, can we get maybe like a 5-minute walkthrough of astropython.org at some point? I think it's, not all of us have looked through it enough to know everything that's available there, so that'd be useful to have.
That'd be great.
Yeah. Anyway, I'm showing you what we did incorporating PySpecket into Glue. So a few days ago I showed you PySpecket, and what we now have is a PySpecket data viewer in Glue that does some things. So you can just drag your spectrum in and do normal things with it, as normal matplotlib window things. But now we also have tools for using the GUI directly to select data. So now I can select a region. Oh, come on.
Could select a region.
Oh, this was, well, huh. Yeah, we're gonna give
Is
that.
that rule about live demos?
Yeah, there is a rule about live demos. Well, okay, that did work, but the other thing that we implemented, and I'll see if this works if I try again now, is, well, first off, we can make this is a data cube, and I'm just showing you a slice of a cube in that image there. We can also drag in the data viewer, and this is now the average spectrum of that whole cube.
Whoa.
Now, within that subset, we can also...
It's a data cube.
Oh, come on. Yes, it is a data cube. This will probably not work the first time, but oh no, it is working right now. Good. Now that is the average spectrum over the red region. So let me, sorry, this is probably on the small side. So this line down here, this first one is the average of the whole cube. The second one is the average over the red selection region. Let's just see if I can do this again. What spectral features? These are hydrogen recombination lines in the radio.
This is so cool.
So that would normally be really cool, yeah. What? So we have spectrum has no object fitter. So I guess we broke things in the last like 2 minutes of hacking. But yeah, wonderful. The fit thing was working. The region select, he can, well, okay. All the stuff that I was showing before in the talk where you had to use key commands to select things. Now you can use the GUI commands as well. The idea is to have both options available. We do have quite a few bugs to work out. Like you want to be able to, right now we can't really select, we want you to be able to pick whether you show both or one or the other and colorize things like that. But at the moment, it's work in progress, but like we've gotten the main thing that, you can use PySpecket to view your spectra now. And so that's where we've gotten so far.
Awesome. Let's switch speakers while we take questions. What's the relevant repo to help?
PySpecket Glue PySpecket plugin.
Yeah. So I can send out a link to it. It's, ultimately it's probably not, but yeah, for now it's just developed in a small plugin repository. So I'll tweet out the link.
Okay, so it's just like on your individual accounts. It's not in any organization.
It's in the Glue organization. It's in the Glue Viz organization.
Oh, it's in the Glue Viz organization as a plugin to Glue.
Yeah.
Got it. Any other questions for Adam and Tom? Cool.
So I did a non-astronomy hack yesterday, and my entire hack lasted only a few minutes of human time. So the way that I've read about these recurrent neural networks, and I actually have this ulterior motive that they might actually be useful for my science. So I wanted to learn about them a little bit, but that's normally not what they're used for. They're normally used, they come with lots of pictures like this. I spent a lot of time looking at those. But generally it's used for simulating fake Shakespeare or fake Wikipedia articles or LaTeX that compiles. It's just gibberish, but it compiles. And even C code that can almost compile. And so I decided that it would be fun to try to do something like this in the context of this conference. And so I made this script with a really good README and lots of tests that that downloads all the issues and the comments on all the issues from a specific repository and saves it into a table or an ASCII file. And so that ends up looking a little something like this for AstroPy. Many of you will see your names in here. It's pretty horrifying. And then I just plugged it into this implementation of this recurrent neural network that I didn't know anything about when I started in the morning, and it's built on top of Lua. I'd never used Lua before, so I had to install Lua. And then what we get, so I ran that for many hours. And
what it does is learn what we sound like.
So what it does is it sees a string of characters and it tries to figure out how to predict the next characters using this very nonlinear model that has this long short-term memory and all these other kinds of weird things that it's really just a collection of matrix operations. But
it only looks backwards.
It's directional in this implementation. You can do it differently, I think. But yeah, so it doesn't know English. It just sees a pile of characters. And so I ran for quite a while. And then here is an example of some of the issue discussion that it gets out. And this is a live demo, so we'll see what happens.
Issue, encoding of assisting as it necessary find to one on IT meant in author. You move to do author. I have something idea. I would have param here won't work to include the open sounds the reference appears, but we have a author. Told Croft.
So it almost learned English. I only ran it for about 8 hours, and we all had many years to learn English. And it was based only on the AstroPy discussions, so I don't even know if that's English. But anyways, this is what it looks like. It didn't really work, but but I learned a lot about recurrent neural networks, and I actually learned what all of these types of diagrams mean. So as this was running in the background all day, this is what I was doing, except when I was getting distracted like Eric.
Can you put these somewhere? The links?
The links? Absolutely. Yeah, sure.
Let's take questions while Leah sets up.
There's some nice symmetry to your hack because the computer was learning about you while you were learning.
Exactly. Yeah, that's true.
That's beautiful.
Yeah.
I don't know what to do with this. Do I do like this? Yes.
Yeah, this is a really good idea.
So how many were actually readable as people drunk having a conversation online?
Oh, some little subsets of the generated text would be, so I would cut those.
Those are the ones you tweeted.
Yeah.
So you spent many hours, I guess, making the network.
So
and then your script uses the network to make new
exactly.
text.
Yeah. So what it is so it has about it has many millions of parameters. So it's just this very 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 high dimensional model, and it's learning on all this data. And so it's just doing an optimization like I talked about in my talk. It's just maximizing the likelihood. No, it was still running. That was the most recent output of it.
Is there anything it could run?
So. If you're gonna win Go, you would run for a week on a huge cluster of GPUs, and I was running on my laptop for a few hours.
Gert, are you next in line? Are you on deck? Yeah. Okay, good. Anyone else? I think now it's time to read your turn.
Oh, great. Yay. So my code is packaged. Yay. So this is what it looks like right now on the master branch. It has a README. It has all the stuff. It has a folder with an init in it and other folders. Has a Travis file. I haven't set up Travis yet.
I need a Travis file for later.
Yeah. And right now, if you want to install it, you have to like copy it or clone it or something, and then go into that directory and do setup.py install. I have tests for it and they run. So if I do pi, hello, wake up. Oh, it's at the bottom. Pi.test dust. It runs some tests that I wrote and they all pass. Yay! And we checked to see that this worked on Stuart's computer and it did. Unfortunately, so I downloaded a bunch of stuff from the AstroPy package template. So if I just say pi.test, there's like some tests in there that don't quite all mesh. I think it has to do with documentation because I have a weird Sphinx build because I tried to build Sphinx, build docs by myself like a while back. So I did some really funny things, so I might redo that.
Can you just type python setup.py test?
No, it doesn't work. Yeah, I tried it. Hold on, let me cancel this. AstroPy helpers. Okay. Python setup.py test. That's the one that gave me like docstring stuff.
It's just to do the doc test plugin thing.
Yeah, that's the doc test thing. Okay. So I'll try to fix that maybe today. The other thing is that I have examples that need to be fixed because now that I've repackaged and reorganized everything, all of my previous calls to the library break. But fortunately, there's been an issue open for that. And I just wanted to show that I am now really keen on test-driven development because it helps me decide where it's going to go in the future and how it's going to act. So I'm moving into a different branch called grain model. And at the bottom, I have a little test that I'm working on called test grain model. And in it, I said, okay, I want to create a grain dist object that's going to be a container for a bunch of the grain properties, which Carl and I kind of hashed out some ideas on how we want to interact with this library of dust models. So in my test, I just have a bunch of asserts to just type checked and say like, all right, I want the grain model to behave this way. I want to be able to call .a and it gives me an array of all the grain sizes. Or .nd and it gives me an array that gives me the number density of the grains. And then some functions that might renormalize it based on some input. So this is kind of how I'm going to outline the future path for the code. And so if people are interested as well, they can look at it and see where it's going and contribute. So that's kind of the basic idea, and I'm really super excited about it. That's it.
So question.
Would you consider not using type for direct testing or use something like isInstance or something like that?
IsInstance?
Yeah.
Let's let's switch speakers while you chat.
Yeah.
There are things that can be string-like without being explicitly called as a string.
You should also maybe consider, now that you're packaging the rename model.
What does your thing look like? Oh, it looks the same as a map.
So, would I have to change the repo name or?
You could keep the same repo name, but
you could keep the same package name, right? You just have to pip install something else.
Take a picture of it with your laptop and hold your head like that.
Yeah.
Am I good to go?
Yes, I think
so. The thing I've been quite interested in is that AstroPy and its affiliated packages are libraries. And maybe this is a bit of tension with, like, maybe part of the reason why IRAF and DS9 are still very popular is that they're sort of more applications. And so they're a bit easier to use. You don't have to understand how you import a library to use DS9, say. And so I've been interested in how we can expose some of AstroPy's functionality more as applications. So for example, 2 years ago, I added a command line tool called fitsheader to AstroPy, and all it does is it allows you to just play around with the header of a fits file, extract keywords, whatever. If you look at where this command is, it's installed in the Anaconda bin directory, but that's because the setup.py file of AstroPy puts it there. And there's actually a bunch of scripts to, say, visualize like contrast stretch images, which Tom made, and some other fits tools. And I think this can really lower the barrier to people starting to use AstroPy, even if they've never used Python before, because it's easy. Command lines are awesome. And, say, amateur astronomers and so on might start using this because it's just a command line tool. So in that sort of spirit, I'm building up on a hack made by P-Dubs last year. I decided to play around with this new Astroplan package that Brett and Brigitta and Eric and many others hacked together. And all it does is I made this little web application where you might put in a date, you might put in an observatory, a target, and you would get a visibility plot out, right? And so all this does here, there's a bit of shading to show twilight, but it doesn't show up with the projector because we have to tune the plots to make them a bit more fancy. But all this does is call a function that's in Astroplan and expose it to the web via a pretty simple interface. And if you want to do this yourself, so I use this framework called Flask, which is pretty nice and popular because it's so easy. So here I just defined this function. And what this function does is it will return this plot that you just saw. And to expose it to the web using the Flask framework, all you have to do is put this decorator on it, app.root. And so if you go to the URL of where the application lives, which is at the moment astroplan.herokuapp.com, and you look at the address of this image, you will see that it's in fact a PNG file, or it looks like a PNG file with some parameters to it. And what happens here is that Flask just routes this URL to this function. It will parse the get arguments you get. Just call the Astroplan plot altitude function, so I don't do anything myself. And we, using some funky bytes.io, we stream the result back. And so my takeaway message is that it is so easy. So we should do more of this. I should probably close the plot. This is going to run out of memory.
I was just about to say, where does this live? Where can people contribute? What's the...
So it's on astroplanherokuapp.com, and if you go there, you'll find the little ribbon, fork me on GitHub. So it's a repository on GitHub called astroplan-web app.
Okay.
And we may or may not move this to AstroPy if this takes off.
Or to Astroplan. Astroplan is going to be an affiliated package?
It is. Yeah, I mean,
Astroplan is an affiliated package? Okay.
Yeah.
Cool. Let's get Megan.
That's exactly right. Gotta fill the time.
Yeah.
Okay. Oh wait, how do I get this to show up?
Can we just look at that for a while?
You can either mirror or just drag it over. It's probably one. Yeah.
Okay. So I have this tool that's meant to be a lightweight interactive image analysis tool from the command line. Oh gosh, I'm used to looking at it on my screen. So it's called imexam. You import imexam. First viewer that I wrote it to work with was DS9.
So could you just move it up a bit?
Yep, DS9 might cover it up.
Yeah, thanks.
Imexam. So you connect. If you don't give it anything, it'll bring up a DS9 GUI. Maybe I should mirror. This isn't really working very well. Just a sec. How do I get it back?
Ah! I mean, I see your settings to be able to.
Yeah.
Well, so let's just.
Let me get it back.
You want to go to display settings? Wow, it is hard. Why is it so difficult?
No, I don't have my mouse here. Okay, it popped up here. There's no mouse.
I just saw it. I just saw it. Yay!
There we go. Okay. Thank you.
Yeah.
Okay, so here's the DS9 window. It popped up. I can display a FITS image in it. What did I miss? Can't type live.
Yeah, if you could move the terminal window to the upper right, that would also. Then more people could judge your typing.
Yes. There you go.
Thank
You can judge my typing there. Okay, so just imexam itself is meant to be interactive for like looking through this image and making plots and good type of stuff. So these are just the basic commands. You can also write your own function and register it, and then you can do whatever you want, like image cuts or something. So if I was going to go through here, I can get surface plots. Oh, where'd my mouse go again? Where'd the mouse go?
Is it all the same keyboard commands as the IRAP exam?
You can make it. I did it originally to be the same commands as IRAP, but you can also change them to be whatever you want. Right, so you can go through, it does line cuts and also fits. You can change the statistics. It can do any matplotlib statistics. So I'm doing a square median now, but you can make it whatever you want. You can also, if you want to save, like you like this thing for some reason and you want to save it, if you hit S, it'll save the current figure. You can start another window if you want to look at other things in a different window. So now that's the current window. So,
does this code live on the internet somewhere?
yeah, so it's at the Space Telescope GitHub site, and it's an affiliated package as well. So my hack yesterday was to add the Jenga HTML5 as a viewer to display. Awesome. So I'll say also, you can, since it runs from this object, you can have as many viewers open as you want. They're all controlled from their own object. You can open and close them. You can also connect to any DS9 windows that are currently open. It's not PS, it's not PyDS9. It's actually just a Python into the XPA. So if I want to close out this DS9 window, it kills the process, and well, it nicely kills the process. So let me open a Ginga window, and you do it the same way. asmexam.connect, but you say viewer equals Ginga NB. So now you've got, I called it Ginga Notebook. So this pops open a window right now in my browser. If I was in the notebook, it would also pop open a tab for the HTML, but you don't have to be in the notebook. You can. If you are, you can then save screenshots of the plots into the notebook. But you can do the same types of things. And I'm going to do something a little different. I'm going to do just a NumPy array. So if I say data is random, I can say a.view data, and my data's in here. And it has all of the Ginga controls and whatever. I'm working on getting the plotting in. I can get the overlay to come, but it's not really listening to my commands for the plots. Hopefully I'll fix that today. But wow, kind of nice.
Yeah. Let's take questions from everyone. I may reveal my ignorance. Is there overlap in functionality between glue and this?
There's no glue overlap.
But there's no glue functionality overlap.
No, I think they should be used in two different types of regimes. This is very much a command line, quick, go up, throw plots, look at things, run up from single objects in an image.
Okay, especially for people who are really like DS9 and they just want to.
Or they want to do all their stuff in the notebook and you want to save all your commands.
Mm-hmm.
You want to see what you've done. It does logging. It does
and
like that.
What about user docs?
There's user docs on read the docs, and then also you can say display help and it'll pop it up in a browser.
Wow, okay. We have a lot of things to teach the community. I think that's a major thing we need to think about, how to spread the word about all these awesome things that y'all are building. Okay.
So in other words, more awesome things. So what I did yesterday morning was start coalescing the discussions we've been having over the week on a time series data object for AstroPy into an ape, which is an AstroPy process for proposal for enhancement. Basically, it's a document describing the new functionality we want to add to AstroPy. The idea of the object is that it's going to provide a base time series class that allows us to do simple, not too particularly complicated, because if you want to do lots of complicated stuff, you might want to use pandas. And so basically some of the functionality we want to add is things like being able to add extra rows to time series, concatenate multiple time series together, how sorting the time series, selecting ranges from the time series, rebinning, resampling, interpolating sample data series, some kind of masking, being able to add and subtract them, and visualizing them. Specifically, a few things that are the reason why we might want this in AstroPy rather than in Pandas, rather than just suggesting everybody use Pandas, is for things like support of AstroPy time, so that we can have like double precision times and change between different time systems. Support AstroPy units natively because they're awesome, and we also and like different variable width time bins, although I think Pandas does that too. Basically, the idea is that probably have a subclass of table, probably QTable, and basically enforce that that table is indexed, has a unique index column, which is a time, and that time is always, the table is always sorted by time. So time is always.
That you made.
This the progress I made is this document. This is it. Like it's a design document. If people want to contribute to this, there is an open PR on the AstroPy 8 repo. Just here. Yeah.
It's got software that'll write the software from it.
Damn, that should be your hack.
Is there a template ape?
Yes, there is. Because that's what I took. That's how I have. That's what I started with.
Yeah, let's just. I think that's interesting. I think there's a lot of people in this audience who haven't seen the template. So this is for proposals to modify the core AstroPy core.
Yes.
Significant. Yeah,
Okay.
significant changes, large new functionality, breaking things.
It's sort of, roughly speaking, anything larger than a pull request, like that's more complex, that you want to have a conversation that's difficult to moderate on just a single pull request. That's one way of thinking about it.
Okay.
And this can be read by people who don't really understand the details of the code necessarily. I mean, it starts off very high level, and it's it's meant to be that way. So we could even advertise it on the Facebook page if we wanted. A lot of feedback.
This will require multiple pull requests. Yeah.
SunPy also has its own version of this.
This whole process is emulated off the process from the Python programming language itself. So if you've ever heard of PEP8, that's Python Enhancement Proposal 8. And there's hundreds of those. That's like if you want to change the Python programming language, you have to submit a packet and then get it accepted, and then actually.
And they're not all accepted. I mean, it's very for AstroPy they've already I think accepted so far.
I think so.
But for the Python, it's definitely not the case.
All right. Sorry to derail.
No, that's fine. Yeah, feel free to come comment on this. I haven't really finished it yet. Pull requests to my pull request are welcome. Yeah.
Are there any other apes that are like people thinking about that are in the pipeline before pull requests? What are other major
examples of?
Yes.
There was one for ND data, which was
Yeah.
basically trying to, because there were a lot of discussions for I guess a couple of years, and the code changed a lot for the ND data. We couldn't agree on something, so this was the way to go and formalize what we thought was important.
What about future ones?
A great one that should be done, that a lot of people in this room are interested in, is something on a new plan for me. That would be exactly the format to have make a final decision on that topic.
So we need a modeling ape.
Well, happy to strut my stuff. Thanks for that intro, Kelly. So first, I'm happy to report that the coffee sprint yesterday was a success. I'd like to propose a repeat today around 3. So what I ended up working on mostly yesterday was putting together an Open Astronomy Conda channel. This will be a fairly short presentation because most of what I need to say is it exists. There's a list of the packages here. So I copied over everything that had been in the AstroPi affiliated package channel over into this. The spirit of this is if you want to add your package, go ahead. It's been set up to be fairly easy to do. Go into a requirements file, and you don't even have to clone anything. Let me click to edit.
So this is how we would add our affiliate package to the.
Affiliate or not. So
Oh, okay,
after some discussions last night, I think the affiliate package channel will probably keep going, but I'll set it up so that anything built there also gets pushed to here.
Okay.
So then, which one do you suggest to use?
I'd use Open Astronomy because there'll be a bunch more stuff in there than's in the affiliated package channel. But
This is for any astronomy software in Conda.
any astronomy software that is on pip can be built with this.
So this file is saying grab this package from pip and add it to the open source channel.
Yep. So once you propose that change,
It doesn't have to be Python, does it?
no, if it's not Python, then you need to write a recipe for it.
Did you need to double click in? Was it float?
Well, let's find out. So I don't know. I know this pull request is going to fail anyway because we're still working on getting SunPy built. But the point is, the point is, once you submit the pull request, that triggers builds on AppFair for Windows and on Travis for Linux and Mac. So you don't have to know anything about Conda packaging yourself. If the build succeeds and the pull request gets merged, the packages get rebuilt and pushed up to the unaccounted channel. And the software that drives that under the hood is also available, so if you want to put together your own channel, you can.
What happens if one of the packages gets updated? Does it automatically propagate? Or?
Switch. Let's discuss
Sure.
the switch.
No.
There's a manual step involved to go up to date.
Yes. Yeah, and I pretty much rely on package authors to do that. There are some ideas kicking around for how to change that.
But you could set up a bot that watches pip, like the Python package and then automatically
So it seems like on some website somewhere, maybe openastronomy.org, there needs to be ways to add things, instructions on how to add things to the channel and also how to use it.
Yeah.
Yep.
Once it's up and running, we'll add it to the main website, I think.
The main Open Astronomy, we have no main website.
I meant because it's an open astronomy,
Yeah.
main open astronomy website.
When you said that you can include things that are not pip installable, do you have a template for that?
You need to run a Conda recipe.
Later today, there will be some example templates. Yes.
There's a whole
Is anyone after? Is Eric last for the demos? Okay, at least one more. We're gonna keep.
Go on astropython.org.
Okay, we'll see how we do with timing.
Okay, so my hack yesterday was largely verbal. I spent a lot of time discussing with people about AstroPi modeling and what to do with it, and especially with the fitting part. And I think a lot of good stuff came out of this sort of in the end. Most of that is not actually written down somewhere, which is bad. So I think we should be writing some kind of design document. So maybe that would be,
for example.
yeah. So maybe that would be a good thing to do for this afternoon. But one thing that Eric told me or challenged me to do is that what he really wants to see is how to do MCMC with like the AstroPi models. And so that's what I did yesterday afternoon. I just coded up a little tutorial and put some background and said why the fitters don't really work for this purpose. And then you can just go through and it kind of generate some data and explains to you how to define a likelihood class. And you can sort of take this, and I just defined a Gaussian log likelihood, but you can sort of take out this line and replace it by your favorite likelihood ever that you just Google Poisson likelihood and copy paste in there. And then I sort of also, just for fun, did the optimization, which is basically what the fitters do. But now you can do this, use the scipy.optimize, not just with the fitters, but not just with the sort of Gaussian typical likelihood, but with whatever likelihood you want to define. And then you can see that it fits. And then I also have here sort of an example of how you can define a posterior class and some priors with the same likelihood. And then you can go and load up Dan's awesome MC package, and it will do MC, and you can plot the chains, and you can plot the parameter estimates, and that's basically it. It's sort of a short run through. It's online. I'm going to tweet the link, but we generally have this AstroPy model ideas thing where probably the AP should go to. And I'm going to tweet the link, and you can play with this around yourself. My little hack last night was you might have noticed that I kept shoving my cameras in your faces all week. So yesterday evening I took the about 1,000 pictures that I took and pruned them down. And the first half of them is now online here on a gallery, and it's lots of pictures of people giving talks or standing up or whatever. Staring at their laptops. That's always a good one. The link is in the sort of overall document that Kelly sent around, and this is about half of the pictures I have, so over the next week I'll add another 100 pictures or so. Well, I wasn't sure how happy people are with me just advertising this publicly. I don't generally like sending out people's pictures publicly because they might not agree in terms of privacy, so I will just keep it in that document.
Yeah, so maybe let's not tweet maybe till the end of the day.
But I'm totally happy for people to use these pictures however they want, and if you want, a higher resolution version or something because Google prunes this down, send me an email.
And I guess if you have any concerns, take a look, and then if you want anything taken down,
that's
and
true.
then once we've all had a chance to take a look, then we can tweet it.
There's also some pictures coming over the next week as I keep.
Good.
Right.
Awesome. How many people are hoping to give lightning talks? Lightning talks after this?
Mine would be just 1 minute.
Okay, so 4. Okay, so we're okay. We're still gonna do. So Tom is at the end of this line to give us to give us the AstroPython tour. And right now, Stuart, the openastronomy.org site is just a static site, right? There's no interactivity.
Yeah, it's a static.
Okay, Abby.
There is a question on Twitter about PyAstro16. Has this been thought of?
Let's discuss later. Okay.
I think there's a meeting on that at 1:30 today, maybe. So I just wanted to report briefly on, we had several small Ginga sprints throughout the week, and we addressed a number of small outstanding issues. I really appreciate all the people that were willing to test and to give me problem fits files and things like that. I just wanted to show you very briefly, a number of people had asked about the notebook feature, and people were interested whether you could embed the viewer. I still don't think that's the best way to run it, but Eric Tollerud, who's played around with this stuff a bit, gave me the secret sauce which I've added to now embed the viewer. So if you have a viewer, you can just do -show to capture the viewer output, or you can do -embed to embed it, and then of course you've got the viewer in there. It's still responsive and does all the things. I still haven't tested this thoroughly, so I don't know whether embedding it may capture some keystrokes that IPython is possibly capturing. I'm not sure. I haven't really, so I can't guarantee that it works exactly the same, but it seems to work pretty well. And you can also just then do show on that same viewer anywhere in the notebook to capture that viewer's output. But then as you scroll down, so here's where I've just, I can capture that same viewer's output, to exactly what it's showing. But as you scroll down and work through the notebook, now the viewer is back embedded, right? So you have to scroll back up there to find it if you do subsequent commands to put things into the viewer or change the viewer. This is not committed, but I'm going to commit it within an hour or two, and you can then
commit it where?
To the Ginga repository, and I will put the address in the PyAstro16.
The notes.
The notes and the email. That's it.
I want to try to get all this done by 10:15, so we have time for the lightning talk. Maybe 10:30. If you put that one in, yep.
No, it's not gonna work, that one. I don't think it's gonna work on my laptop.
Are you a VGA? You want the VGA, right? How come there's no VGA? That seems kind of.
I'll be very short. I worked yesterday on a very simple user tool in GWCS, which allows having two sets of matching points. For example, XY pixel coordinates in an image and the corresponding array in JAG to create a WCS for this image. And basically, this is just a prototype, and I'd like to hear feedback. So other than the two sets of points, a user can provide a projection or a fiducial for the reference point on the sky. And what it does is it fits, makes the projection to a tangent plane, for example, or whatever projection a user wants to use, and fits polynomials to take out the distortions and creates a GWCS WCS object. This is one of the few tools available now in GWCS. If anyone has ideas for other tools, go to the website and file an issue or appeal.
Do you have a link to that?
It's a PR
Let's
on the
switch
site.
Okay.
It's a PR.
GWCS.
This is generalized.
I've been waiting for this for a long time. It's gonna be
Right. New things. WCS I'm used to. GWCS.
It's WCS, but more general.
And the important thing for those of you who are wondering why we need yet another another WCS package is that all of the existing WCS tools do not do distortion. So that's why we need it.
You're using your own dongle?
Yeah.
Okay.
I'm guessing this doesn't have micro HDMI.
Oh.
Oh, it totally
does. That was
Oh, really?
That's all right.
Well, my Linux laptop is totally messed up its display. I only wanted to show a one website though, and you can look at it later. My hack yesterday was preparing for Astro Hack Week, which I really just wanted to get up here and advertise. It's going to be August 29th to September 2nd. So it's kind of similar along the same lines as this. There's some differences, more statistical based and more of a summer school format, but it's all sort of hacking and unconference type stuff. So a lot of people here should be interested. And one other thing I did yesterday that was a hack was talking to my boss on the phone, and I want to take the opportunity to say that I guess we're going to have a postdoc open, which is very software heavy. It'll involve...
Where?
Oh, in Berkeley, which is very nice. Slightly less rainy than here.
Tom, can you switch while we... Let's do astropython.org now.
And where is Astro Hack Week?
Astro Hack Week is also in Berkeley, which you would have seen if I had put the website.
It still says date to be announced, though. Did you reveal for the first time?
I was working on the website yesterday, but haven't finished it yet. So it'll go up next week. Hopefully the application will go out next week too. So.
Yeah, that's right.
What's the type of application of that?
I don't know.
Is this yours?
Yeah. Yet to be set.
Yeah, come on. What do I need
Do you want
to
a mirror?
here? Where is mirroring?
Gather windows.
Gather windows.
If you gather windows, then we'll find the. There it is.
Mirroring.
Click on it. Click on the one in the back. Bring that up.
There we
And then arrangement.
Arrangement. Yeah.
And then mirror displays
Okay.
lower left.
I did it before, but okay. Voila. So now,
Now I can help.
okay. So a year ago for Google Summer of Code, we had an amazing student from India, Aman Junjunwala, came in, and we had the idea to essentially take the old astropython.org site, which I'd written years ago as a Google App Engine, and it was the code base was complete crap. And so we had him come in and just rewrite the whole thing from scratch using sort of all new technology. And he was really brilliant, and he just did the whole thing like bam. So the idea is to actually have this sort of community portal. And the most important change from the old site was that anyone can log in and authenticate and contribute content. So that hasn't happened so far. Maybe it wasn't advertised well enough. We sort of had a soft opening at some point. But this is maybe the opportunity for the people that do these kind of things to start using this. And so the first thing is, you have all this sort of stuff like a timeline, and you'll see it's not super duper fast. We could use some better servers on the back end.
But so we should all make accounts. We'll probably need to submit our packages, descriptions of our packages, I'm assuming. And it's the place, make accounts and submit our lessons.
But so it's nice. Just what I'm showing you right now is what you get if you aren't authenticated. But it has all this nice JavaScripty stuff, and it looks like a nice modern site. It's pretty cool. But the important thing, of course, is actually adding content and making this a real website. And so you go up here, and there's this nice stuff. You can scroll down and basically get sort of the latest stuff that's happening, forum posts, all this nice stuff about contributing, social. I mean, it's got all these great widgets. There's even a link to an online Python interpreter that you can go to and play. Just start up a
How would
Python.
an average astronomer wants to open a FITS file in Python? How do they find that?
Well, what's it? There you go. So.
Right. Except we don't want anyone to use PyFits anymore.
The site is a little. I mean, basically what we did was he did a bulk migration of the content from the old one to the new one. So the site needs curation, and I don't have time to do it all myself.
Okay, that's what.
So that's what we're looking for, is people to come in and curate. So if we want to add content, you authenticate, and you can.
Well, how would we deprecate? So we also want to get rid of ASCII data, right? That's also.
And in fact, these packages.
How do we?
They can be marked as deprecated.
Okay.
I don't want to. Let's see if I can.
ASCII data, isn't that?
ASCII table.
Now they want astropy.io.
Yeah, that's deprecated.
So if we log in, will we have
there is
permissions to add a deprecate tag?
Let's see.
It'd be nice if it had a pointer to what you should use instead, though.
Yeah, to edit it. Can anyone edit the things, or can we only? Are we going to be given permissions?
Just slow down.
Sorry.
The first thing I'm going to do is authenticate.
Okay.
And I authenticate on this via GitHub. And so I clicked on the little GitHub thing. Okay, now it says TLCraft. And so I should be able to edit this and confirm edit or subject. Okay, so this doesn't let you change the status, but I can do that as an administrator. So we at least have, there's a way that you can mark packages as deprecated, and so as a contributor, you can go and put in, I think that on the front page.
So we probably need to recruit some people to be admins.
And I was going to say, maybe this is something that could be done this afternoon as a mini sprint or something, like just for an hour. Get anyone who's interested in helping moderate this could sit down and figure it out. And
So just to be clear, down at the bottom of the front page, we've got this box where you can just submit comments. And so you can just say PyFits is old, needs to be deprecated, and that goes to the admins list.
Okay.
Okay.
I mean, that's a start. That's at least a workaround. So obviously this hasn't been like really hard tested, and I pray to God there's nothing really wrong, because I mean, Aman is still accessible, but he is doing his own stuff. I think he's doing a research project at Caltech this summer, and honestly, he's the only one that knows the code, so it's always a little bit scary. I mean, you know, it's a big Django app, and so probably someone could figure it out. I mean, it's written well enough. But I just want to demonstrate adding a package, which is a really key thing that I want to crowdsource. And so once you're authenticated, you can add a package. Okay, and so let's do Halo tools.
Can we, whoever's the first lightning talk, who I don't know, can we get on deck?
The list is on the board, right?
Right. I designate you.
So the thing to notice is that you can put in your input in Markdown or in a WYSIWYG editor. I prefer Markdown. Generally, he gave space for an abstract, but that doesn't always make sense here, and so I'm just gonna copy this. I'm enjoying my Markdown coding now, so it's kind of nice because you have, let's see, I think if I, I've, that me? We've got a homepage URL. Sorry, this. Actually, these are the URL to the docs. I guess the homepage we're going to call the GitHub.
Oh, good. And we're given a library of tags to choose from. So excellent. If you scroll down a little bit,
Yeah.
display the tags.
Okay, and we're going to recommend this, and it's active. And so,
affiliated.
What's that?
The URL has a dot on the end.
Oh, thank you. Okay, so who wants to help me pick the tags?
I don't know anything about Halo tools. Galaxies?
Do we have a galaxy?
AstroPy, well,
Cosmology.
soon to be AstroPy affiliated. AstroPy affiliated. Yeah, you still have to.
Call it AstroPy affiliated.
All right.
I
I think we just
close
need to
enough.
move on because of time.
So we publish it. Okay, so your post has been submitted, and this goes for moderator approval, and it should be approved.
How many moderators do you have? Let's switch while we ask more questions.
It's a good question. I think right now it's 3. It's me and Aman and Jane, so we need to address that.
Okay. Cool. Thank you.
So please, people get excited about this and start using it and start using the website. And there's a whole bunch of stuff. There's places to add tutorials. For instance, had time, I would add in this little model ideas tutorial. I mean, the idea is to not set the bar too high, so that, for instance, like the AstroPy models and MC thing that we just saw, you just put it in there.
I think we should do a little bit of a.
I mean, there's a little bit of a curation,
of a sweep cleanup before we at least advertise too broadly.
Yeah.
But we definitely need people involved. All right, so now we have a lightning talk. 5 minutes.
Sure. So I'll talk a little bit about this new package Trippy that my collaborator Wesley Fraser has written over the last few months. I just got involved a couple of months ago because I wanted to use it, and then somehow I ended up doing a bunch of bug fixing, and it finally got me using GitHub. So that was excellent. So Trippy is trailed image photometry in Python for doing photometry on moving objects. So it'll probably mostly be relevant for solar system objects because when you're close to Earth, things move during an exposure, mostly due to parallax and also partly due to just proper motion. So I'll just cover a few of the features of Trippy. There's some functions for setting up and running S-extractor from within Python, and then there's a PSF star chooser, which reads in the catalog that S-extractor produces and plots it in this little window where you can see the full width half max and the RMS of the fits that S-extractor produces, which allows you to pick your PSF stars. You can zoom in, which allows you to ignore all of the junk that aren't actually stars. And then you can click on all of these sources and you can see just the image cutout and the profile of the source, and right click to reject anything. So once you've rejected all the not good PSF stars, the blue sources will be used to compute the PSF model, or well, you can use that. You can use your own model, I guess. So you can produce a PSF model. Trippy can also produce a trailed PSF to replicate the trailed moving object. So you just have to tell it the rate of motion and angle of motion, and it uses the PSF from the PSF stars to produce this little model. The model is also used to produce aperture photometry, or to produce the aperture correction, because the aperture when you're using a non-circular aperture is, of course, different from just the regular circular aperture correction. Then there's the photometry function for actually doing the photometry. Plops down the pill-shaped aperture, which is just the radius that you define, a length that corresponds to the rate of motion, and your angle of motion. There's the ignored area and then sky area around it. It does a little bit of outlier rejection, but if you want to be really careful, you can zoom in and it'll just use the zoomed in part of the sky for your sky background. So I've been using this on Kuiper Belt objects, which are marginally almost not trailed, but occasionally they are, and just to make sure that we actually get the photometry as well as we can, I've been using this in a project that I'm involved in using CFHT and HyperSpramCam. We got some engineering time images from HyperSpramCam last year to observe light curves of a bunch of trans-Neptunian objects. And this is measurements that I've done using Trippy. I compared this with photometry done with S-extractor and just a circular aperture, and it's better than both. S-extractor is not good. Of course, because my objects are hardly trailed at all, it's not a lot better than just a circular aperture. But if you are in the case of like something that's this trailed, it makes a huge difference, because if you had a circular aperture that was big enough to actually incorporate all of the light from its source, you have a lot of noise. So basically, using the pill cuts out a bunch of the noise that you would otherwise be including, increasing your signal to noise. And how am I for time?
You have about a minute left.
Okay. So Trippy also does have, it has a little wrapper for MC. So you can also MC fit the trailed PSF model to your image. And that works reasonably well. That's currently not really used for anything other than this, which is cool. It could probably be used to also do PSF photometry, although it's not clear that that would necessarily be better than the aperture photometry. And that's it.
I should know who's next. Russell Owen? And I think what I'm going to propose is that we do one more and then do these at the beginning of the next session. Is that, do you, do Megan Sosi, Tom Robitaille, and Eric Toller? Oh, you're done. So you've done your lightning talk.
And I think ours are each just like 2 minutes.
2 minutes, so do you want to do them now or do you want to do them at the beginning of the next session? Oh, okay. Okay. So we'll just go 10 minutes late to talk.
We can start the next session 10 minutes late, so we can start at 11.
Sounds good. Do you need help?
This will just plug in. Oh, there we go.
Yes.
Now I just need to get the mirroring done. But see. Well, it looks, yeah, I'd rather have it on my own screen too. And not sure where to get the mirroring controls from. What does that say?
If you scroll all the way down to open display preferences. Arrangement.
Gather windows, arrangement.
Then check the mirrors.
Yes, I'm trying.
Yes, the mouse
It's just a
is
bit of a challenge when I'm looking at the wrong thing. Okay. So, quit system preferences, play this. Okay, so I'm here to try to encourage you to use Python linters. And I'm curious, how many of you have one installed in your editor right now?
As of
Not
yesterday.
bad. Hey, well done. Okay. So, what is the problem we're trying to solve? Linters catch errors early. They can catch annoying syntax errors, which is no big deal because Python will get them for you. But how many of you have written up code? You save it, you run it, oh, I've got a syntax error. You edit it, you save it, you run it, oh, there's another syntax error. Gets old fast. A linter will catch that all before you ever save it and run it the first time. And then there's the errors that the Python interpreter won't catch until that line is executed. And if that's in some obscure branch that is rarely run and that your unit tests somehow are missing, you have an embarrassment waiting to happen at some future time. So things like using a variable that was never defined. Maybe you misspelled it. Maybe it used to be defined and then somebody took it out of the code. Or you have a package that you're using, but hey, you forgot to import it. And then linters can also show you things about, they can show you unused variables, packages you import and never use, bad style, stuff like that. They're great. So the available linters include PyFlakes, very basic, gets lots of errors, doesn't try to do anything else except unused variables and unused imports. Flake 8 adds together PyFlakes plus a tunable PEP8 style checker, which is very useful if your project has style guides, which I think most of them do. PyLint is a different linter that is extremely comprehensive and verbose, doesn't do PEP8, but it can find a lot of things, so it is also useful. PyChecker, unfortunately, seems to be moribund. I don't think it's been updated in 7 years, but it actually could catch cross-package errors. You import a package and use a symbol from it, but that symbol doesn't exist, it will tell you that. But it's very slow, and it only works on Python 2, and it has lots of false positives. Still, if you have code you really care about, it can be worth running it if it's Python 2 code. So most of you, I hope, will be running your linters in your code editors. Most editors support this, including Sublime Text, my favorite, Atom, Emacs, Vim, probably most IDEs and other editors. I don't know, but if you want help installing in the first two, I'm around. You saw the hands. People can help you. This would be a great time to do it because the expertise is here. Of course, you can always look on the web.
Yeah, I installed it yesterday in Sublime Text. It was not trivial.
Oh, did you have the package manager already installed?
No.
Yeah, so if you're running Sublime Text, you want to install the package manager first.
Yeah.
It's not so bad after that, but there's a little configuration involved. So I wanted to give you a live demo.
Wait, can you first just tell us which is the best text editor?
That would be a lightning talk where I'm struck by lightning. So, this is an old editor, BBEdit. I used to use it. It doesn't have a live linter. That's why I don't use it anymore, actually. I wrote this quick sample to show you something that's just riddled with errors.
It looks pretty though.
Yeah, thank you. So I challenge you to try to count how many errors you can find quickly.
Somewhere in the tabs.
Ooh, that quote. Yeah, is there a tab in there? Is the quote? Yep.
Yes, there is a tab in there. I'm not sure you can see it from that.
Are we supposed to count them out loud?
That's all right. You've had a chance to look. Let's see what a linter can do with this. Actually, before I do that, I'm going to show you a different example. I think this is not terribly hard to find a reasonable number of errors. You might not find them all, but you'd find a lot. But now let's look at this. This is some code that I edited. It's in our repository, and I found
LSST code.
This is LSST code that I was working with a few weeks ago, and it goes on and on and on. It's got one fatal error in it. That is, if you run this code and run the right branch, you'll get an exception. The linter showed that to me. So let's have a look with a different editor. So here is the short example with the linter. So you can see the nice little dots on the left that are giving you some hints if you want more information. Hello? Okay, so there is a list of the problems that it has found so far. Now, as you fix them, it may come up with some additional ones. And rather than take your time, I'll show you as you can live change things. That semicolon turns into a comma. This string was incorrectly terminated with the wrong character. And of course, print is now a function which catches me all the time. So we're getting down there. So what have we got left? I snuck a tab in. Not easy in this editor, since it really doesn't want you to do that. And I think I have one trailing white space. So we're getting close.
And you don't have to import NumPy? Is that
I don't have to import NumPy. That's very good. And is none is better than equals none. So that was a style issue. It would work either way. So there is a cleaned up code.
Is none is safer.
Is none is safer because it works for NumPy arrays and will continue to work the same way you expect it to for NumPy arrays in the future. So there's one remaining error in here that the linter does not catch.
3 white space.
Ret val is not necessarily set, and that's a fatal, nasty error. So linters are not perfect. Yes, I think you're probably right. And so here's the long example. And I took out some boilerplate and a long doc string and cleaned up some of the errors so that it would be a shorter list. Now, these are mostly warnings. There's only one nasty error in this package, but that was all in committed code. Scary, huh? So let's find the nasty error.
The bells have it wrong.
NumPy.
You have about 1 minute left.
Okay, so we imported NumPy, and we didn't import NumPy, but there it is being used. And if that code runs, trace back. So use a live linter. Saves a lot of embarrassment.
Only if password is.
Eric?
Oh, me first.
You're closer.
That's fair.
That's why I chose you.
Wait a minute.
So Tom, do you want to make Tom, if you want to speak, do you want to make your way out so you can be on deck?
Yeah. Sounds good.
So this was inspired by someone who made a mistake I didn't realize people would make. But we're going to find out right now whether anyone in this room is going to make this mistake. And if the answer is no, then I can stop right now. So raise your hand if you think you're pretty sure you know the right answer to this question.
What is an API? Oh.
Okay, not everybody, so we're going to keep going. All right, so an API is an acronym you hear all the time, right? It's an application program interface. In fact, I've realized in recent years, especially today when a Google Summer of Code student made this mistake, that not everyone understands that an API is really 2 different things, right? So one is the thing you see all over in Web 2.0 or 3.0 or whatever fancy, newfangled speak you want to use, about specifically web interfaces, right? So web APIs are a thing that's cool and everyone thinks they're supposed to do that. And that is a good thing to do, but the point to be made here is that this is an example of web API. It's a thing that you use specifically to interface with the HTTP, the protocol that powers the World Wide Web. Right? So this is just an example of what a web API is. This is GitHub's API, where it basically just says, like over here, if you hit this URL, you get back, with these parameters, you get back a response that looks like that. So I've come to realize that a fair number of people think this is what an API is, that this is the only thing an API is. That's not the case, right? This is another use of the acronym API, the thing that specifies in, let's say, Python, that a function called getICRS-coordinates takes a name and returns something else, right? This is just a list of all of the functions. The better example is this one, where you have some class that has a bunch of parameters, just the whole description of how you interface with the code. And the only point I really want you to take away from this is that an API is actually a different thing in a different language. A web API is not the same as a Python API, but people seem to use these terms interchangeably and not understand that they are specific to whatever language the API is operating on. All right, that was it. That was me being totally pedantic. Which is my favorite thing to do.
I think it's important.
Okay, so mine is very short. Back in January, the AAS Publishing underwent some big changes and reorganized some of the main sections in the journals. And one of the sections in the AAS journals, which includes basically AppJ, AJ, AppJ supplements, and AppJ letters. So one of the new sections is instrumentation, software, laboratory, astrophysics, and data. And the lead editor for that is Chris Lintott. And there's then several editors in that section. I'm the scientific editor for software papers in that section. If you're interested, you can go to the homepage of the AAS journals, and there's a new policy on software that Chris and I wrote. And essentially, it says two things. So it says, if you want to write a paper about software, then essentially AAS journals now accept software papers which don't have to have novel science in them, which is a big improvement. And also there's no, so first you don't need actual scientific results. You don't have to have a 20-page paper. So if your software is adequately described in 3 or 4 pages, then that's fine, as long as the software is novel to some extent. Then that's fine. So I would like to encourage you all to think about publishing papers, and specifically to AAS journals. And
I also suspect we're going to be referees.
yes, I mean, so exactly. So actually, some of you may start to become to be asked to be referees for software papers. Don't be surprised if that happens. It does raise interesting questions about how do you review a software paper, because there's a scientific aspect of the correctness, and then there's also things to do with the actual how the software is published. There's no requirement that the software is open source, but we strongly recommend it. The other thing that's
so hold on, the editors recommend it, but we as referees can also be very vocal about that.
Exactly. Yes. And then the other thing is, this is more minor, but actually there's often a lot of talks at these conferences, PyAstro and .astro, about how to give credit to people, and in particular how to cite software. And so we actually have explicit guidelines now. We've added, basically AAS Tech template now includes a software clause at the end, which I've been advocating for ages. And you can basically, in there, you don't have to put the full acknowledgements of the software. You can simply list the software that you use with relevant citations, which means you can now, if you were worried about page limits and things like that, you can include a lot of software in a very short amount of space. We recommend citing, for example, the paper if there is one, and optionally the Zenodo entry, for example, for GitHub repository, which gives you, so the Zenodo gives you a DOI. So we don't recommend citing GitHub URLs directly. Always, if possible, use a DOI. And then you can also cite things like ASCL entries and things like that. So if you have any questions about publishing software papers, then please come and talk to me, any point today.
Awesome.
Thank you.
So I'm curious, did the paper we submitted on Thursday come across your desk?
It may have.
Yes. That's the system working.
Yeah. So don't blame me if you get asked to referee papers or things like this. In general, it's it's not my fault.
No, it's good. That's
it's
what
good.
we
Exactly.
wanted.
Yeah.
Yeah. All right. Let's break for coffee and then meet back here at 11:10.